Hey friends, I'm Scott Hanselman, and it is Deep.net, and this is a very special episode of Deep.net. I'm going to take my glasses off because we have Eric Erhardt, the principal software engineer on .net, who's going to talk to me all about AOT, ahead of time compilation, not JIT, not just in time, ahead of time, native compilation. It's really it's not new, but it's like being refined. It's kind of like, when did it start? When did we start thinking about AOT? And when did it become, now we're serious about AOT?
Well, I mean, we thought about AOT back in the .NET framework days, right? Like,
yeah,
there was NGen, and you could take your app, and when you installed it on a customer's machine, you'd NGen, and it would get all the native code compiled at that time. And so that was, I don't know exactly when in .NET framework it was, but it was very early in .NET framework.
If you're thinking about native generation, the idea is at some point IL, intermediate language, becomes whatever that processor is, x64, x86, ARM, and it's a matter of, does it happen at the last possible second? Does it happen a couple of times after we've run this loop and we go, now we know enough and now we're going to be native? Does it happen NGen? Because people remember having that NGen background process running and people didn't know what it was. Why are we chewing on all of these DLLs that were laid down during our installation time? But why do I need to think about it? Why do I need to know that AOT is a thing and maybe target it? Or why can't I just live my life?
Right. So there's obviously a lot of advantages to a JIT, a just-in-time compiled language and having this intermediate language. So that way I can take the same DLLs that I built on my Windows machine, that's x64, give them to you and run them on a Linux ARM machine, and it works, right? Because there's no native code there. The machine code isn't there. It's just the IL. And so the portableness is a huge benefit. And then also, when you're on the actual machine that you're running, you know, hey, this machine has these SIMD operations, so I can specialize the code for the machine. And so that's what the JIT is able to do. But that obviously takes resources and it takes time, right? And so there's certain scenarios where you don't want to take that at runtime time to spend generating the machine code for your application.
Yeah.
And sometimes you can't, right? Like on an iOS device, they don't allow you to JIT machine code. And so there's also security in the cloud and the servers. There's certain layers really low in Azure that won't run JITted code. And so there's environments where you can't do JIT, but there's a huge advantages to it. So that's why it's like the default in .NET. And so what native AOT brings is it allows you to, like, a spectrum, like options, if you will, of how do you want to run your app. And so this is just another way that you can run your app now.
Yeah. I imagine this kind of like slider bar of like, how hard do I want to chew my food? And like, how much work just happens on the client and versus how much work happens on the developer's machine. Like, I'm going to compile this. How hard do you want to compile it? Do you want to compile, like, do you know everything about the end? Do you, like you said, SIMD, single instruction, multiple data, like it's parallel processing. Not every processor has that instruction. I would need to know a lot about the end game for this thing that I'm writing. If I know a lot, if it's an edge device, if it's a Raspberry Pi, if it's a small IoT system or even a microcontroller instead of a microprocessor, and it's never going to run and need to be portable, there's a lot of value in AOT because I know where it's going to end up.
Yep. So another kind of slider, I made this little slide.
Oh, I like little slides.
And like the slider that I have is kind of on the left is like anything you can do in .NET is going to work. And so what these are, the different options you can publish your .NET app as, the major publish options. And so anything on the left is like anything you can do in .NET, you can, when you default publish it, it'll work. If you self-contained, where the default publish in .NET, right, you expect the .NET runtime to be on the machine already, and then your app comes in and then it finds that default runtime and then it uses it to run. Well, you can self-contain your app, which means when I take my app, take the .NET runtime that I'm going to use and bring it with my app. That's what self-contained means. It's a self-contained app. It'll run on any machine, so a machine that doesn't have the runtime on. And then we were talking about AOT. There's a form of AOT called ready to run, which will take your IL code and next to it in the same DLL, we'll put the machine code in it as well. And so all three of those publish options, you can do anything in .NET, right? So that's kind of the left side of the slider here. And as you move further over to the right, there's more restrictions on what you can do. And so another publish option is single file. So you can take all the DLLs in your app, put them in one single file into one exe. And there's just a handful of things that you can't do in there. Like you can't do like assembly.location, right? If you got an assembly, if you try to get the location because that DLL isn't there anymore. So then way far on the right side in your publish options is there's trimmed, which means take my app, but trim out all the code that I don't actually call. Right? Because there's a bunch in the runtime, or maybe you pulled in a third-party DLL, but only used a couple methods out of it. So you can trim the code out of your app, and now it's smaller, right? So it really works well with self-contained. Well, today it only works with self-contained, but if you bring all of the .NET runtime in and then trim your app, and it cuts out all the pieces that you don't need, right? And then the very end of the spectrum of like limitations is when you native AOT, it kind of combines all the things on, it makes it self-contained, it makes it ready to run AOT, puts it in a single file, trims out all the things that it doesn't need, and then you see at the bottom that JIT compiler goes away. Like there is no JIT compiler in a native AOT app, and so there's a bunch of things that you can't do because of that, and you get like warnings or runtime errors if you try to do them. So for example, in normal .NET, you can generate IL on the fly and then run that IL. Obviously, you can't do that in native AOT because there's no JIT compiler there.
I want to compliment you, by the way, on your slides, because if anyone on deep.net or watches deep.net has any questions that we may have tried to sneak a marketing person or a PM on the show, these slides are proving that you are the hardcore dev that we all know you to be.
Oh, yeah. I drew this line with a ruler. I was pretty proud of myself. Made it really straight.
But this is great because you're visualizing it in the same way. And I love that you had that visualization ready to go, because that sense of choice, this line and this spectrum, I would say a non-trivial amount of .NET developers just don't even know that this is a choice. They just accept the defaults, and you called it out as default over on the side. And it'll be great. It'll be performant. But if they start learning about these other options and start moving towards native AOT, if it's appropriate for what they're trying to accomplish, it could offer a lot of benefits.
Yep. Yeah, for sure. For sure. So we can maybe dive in a little bit.
Let's do it.
And I'll show if I say .NET new console, I can pass in this AOT flag. Now it's two dashes.
I never know how many. It's like 2 or 3. I don't know how many hyphens I'm supposed to put in there.
Yeah, I should have did one more. I needed to put it in a folder. No. So I'm going to put it in the hello folder. So you'll see like the code, same as always, right?
Yep.
Console line, hello world. The thing that changed in here is this option got set in my project, right? Publish AOT true is the flag that you use to say, I want to publish this app as AOT. And so when I .NET publish this app, you see it takes a little bit longer than compiling, right? Because you're going to compile it into IL, and then you'll see it'll call ILC compile. It'll compile that into native code, link native. And now you see that I have this app, hello.exe. It's 1 meg. I could take this exe, give it to you on your Windows x64 machine, and you could run it no matter what .NET runtime was on there, right? I can.
Okay, well, let me ask a challenging question though. If I were going to use, GCC or Visual C, and I just did if I was doing C++ and I did a C out, or I was doing just a printf or something, I would get a smaller than 1 megabyte thing. Now I know that that's apples and oranges, but it's worth at least calling out what's in that meg. Why isn't it 4K?
So everything to load up the .NET runtime, like string, console, like all the stuff inside. It's kind of the garbage collector is still in there, right? That's a decent chunk.
.NET is still in there. It's still .NET.
It's still .NET. The just-in-time compiler is what kind of gone away, right? And so there's no compiler, there's no JIT inside of it, but there's still other .NET runtime stuff, right? Like the type system, the GC, etc. So that's, if you want to get really crazy, Mikhail on the runtime team has a couple blogs about taking a C# Snake app, right, and getting it down way small, like smaller than I even thought possible, more like what you would get for C++ apps, right? Like in the 10K.
Mikhail's a beast and is legendary in the how small can you get these things. It's pretty amazing stuff.
Agreed.
Yeah.
But like, we don't expect everybody to know how to take out the GC and
right.
Yeah.
Well, the reason Mikhail does that is you tell him something's impossible and then he'll do it anyway to prove you wrong. Right.
Right. Exactly.
So shout out to Mikhail. In this case here, that meg is super small, and you would not be able to run ILDASM on that. You can't run a decompiler and get IL anymore.
Right. Exactly. Like if I'll spy this, it's going to say that this is not a .NET assembly.
Yep.
PE file does not contain any managed metadata.
Does not contain any managed metadata. Okay. So we've proven that is real.
Yep.
Dig it.
And so it's like, okay, great. I can hello world, 1 meg. That's fine and dandy, but I want to do something real, right? I don't know. In .NET 8, we really worked on, well, what if we want to make web servers like this, right? Like, what if somebody wants to build a web API, put it in a Docker container, ship that Docker container somewhere? It's small because you don't want to like download all of the .NET runtime just to run, just this web API app. And so if I .NET new web API AOT, so we'll call this hello ASP. If I look at this app, same
thing. The one
thing.
that you made there, that you said .NET new, and you said web API AOT. Before you said -AOT.
Yeah, this is kind of a wart in our template story. Like, we originally did have it web API -AOT, just like console.
Sure.
There was limitations on the existing web API template and what we could and couldn't do inside of the templates to make it. So just making AOT was just a -- right? And so we made a brand new template called web API AOT
in order to have more control. Okay.
Yeah, there's another one. So there's .NET New Worker, which is kind of like an ASP.NET app. It's like a background worker app. This one, there is a -- AOT option for it to make it more like, we had all three of them originally in .NET 8 like that, but there were complications in the template story on why we had to do it this way for web API.
So let's explore that CS proj again.
Yep. So you'll see the same thing in here, this publish AOT true. We also, just to call out, we also stick in invariant globalization true when you publish for AOT. The thinking there is like your globalization story, especially on like Linux, right? Like you have to have an ICU installed on the machine in order for your globalization to work. And invariant globalization means basically you don't have in globalization like all the cultures. It's the invariant culture, which is just the hard-coded, $ for a number, a currency symbol, hard-coded basically date, time, formats, et cetera, et cetera. And so there's performance, like it gives you better performance to use the invariant globalization. Like there's code that can get trimmed out, smaller memory footprint, faster startup. And so we decided when you're going AOT, your default is invariant globalization. And then if you do need to use globalization, you can just come in here and delete it.
Right. So if your application does not explicitly require any globalization support, it'll run in this invariant mode, and that's going to call out globalization sensitive stuff like string comparison, sorting, casing would all be using the invariant or the default.
Right. Formatting, parsing, right? If you want to parse like a double or any sort of numbers, right?
Yeah.
Date times, etc. So that's just kind of a side thing there. But the important bit here
calling out because it is a size thing, right? This is how much, if you want to reduce the dependencies in the size of your application distribution and you don't need globalization support, invariant globalization gives you kind of the best of both worlds.
Right. Yep, exactly.
All right, dig it.
And so here in our program CS, like the middle should look pretty familiar to ASP.NET developers, right?
Mm-hmm.
We call web application, in this case, since it's AOT, usually it's web application create builder, and that brings in a bunch of stuff with it, right? And in trying to get these ASP.NET apps as small and as slim as possible, we made a create slim builder. We also created a create empty builder, which has nothing in it, right? There's no defaults in it. But for the template, we use create slim builder. With that builder, you can add things into your services, and then this is using minimal APIs. So we're making a to-dos API, and it just has two endpoints, right? The default endpoint, which just returns a hard-coded list of to-dos, and then give me the to-do by ID, which finds the to-do with that same ID and then returns it.
And create slim builder. So create builder will give you logging, it'll give you HTTP3, it'll give you HTTPS. Is that just to make it smaller, to remove those things with create slim builder to basically have a lighter weight default? Am I right? It doesn't include HTTPS, but I might not need it in my basic because I'll terminate my HTTP elsewhere. I'll terminate it in Nginx or upstream.
Yep, exactly. Yep, create slim builder actually doesn't have HTTPS in it, but you can just, if that's if you want to start with the slim, you can always add it in later, right? There's a line to add in HTTPS, or you can not use the slim builder and just use create builder, and your app's a little bit bigger. Like one of the biggest problems with HTTPS was that in order to do cryptography, you actually had to pull in the HTTP client as well, right? And then, so it's just like these, as you're trying to make your app smaller, sometimes like trimming one little thing can trim out a whole chunk of code or of infrastructure. And
that makes sense.
It was a couple megabytes, right? That were able to be trimmed on Linux because of this. So the things that aren't familiar to people is kind of, this part and then this part down here. And they're connected, right? This part up here is saying, configure my HTTP JSON options, and this serializer options is the JSON serializer options, right? Like in our API, we're returning objects, but to the internet, it's going to be JSON objects. So these objects are going to get serialized by system text JSON. The problem is, by default, system text JSON uses reflection and potentially like generates IL kinds of things at runtime, right? Which we talked about, like you can't do in native AOT. And so in order to work around or to solve that problem, we use what's called the source generator in JSON. So there's this JSON serializer context. And if you derive from that class make your class partial, and then mark all the objects that you're going to serialize. I should pull this up in Visual Studio. I don't know how to do this in VS Code. In Visual Studio, you can see the code gen that gets put. Could have filled. You'll see for my to-do, a bunch of code gets generated by that source generator. And what this code does is it tells the JSON serializer how to serialize and deserialize these to-do objects. And so now the serializer doesn't have to do reflection at runtime or generate an EIL or anything. All of that stuff happens during your build, right? Like that's the beauty and the magic of source generators.
Is this the same thing? Is this source generator that we're seeing beforehand effectively the same thing or exactly the same thing that happens during the jitting time?
I would say it's maybe not exactly the same thing, but effectively the same thing, right? Yeah. Like at runtime, what gets built up, these JSON type infos and JSON, all these things, right? Like this is kind of the guts of how the JSON serializer works underneath. And so these things, we had to expose a bunch more APIs so that way the source generator could new up these objects and feed it into. Yeah.
And this is like a good reminder. It's a very visceral reminder to us of like the whole idea of .NET was this flexible just in time, and a lot of work, whether it be reflection or generating XML serializers or just serializing an object as JSON, required you to introspect and reflect on objects at runtime because you wouldn't know stuff. So you're having to push everything as far left as possible. And source generators are coming in super handy here. So another example of like people that work at Microsoft take source generators for granted. There are .NET devs that are watching this, watching Deep.NET, that may not even know what a source generator is. We'll probably go and do a deep dive on those at some point as well. It's a super, super useful concept, and it allows you to do a lot of damage in a positive way.
Yep. Yeah. Yep. Source generators are Roslyn extensions that you can recognize patterns in your code. Like in this case, it derives from this class, has this attribute, and then you can generate more code into the project to be used. So like in this case, the to-do serialize handler, this should look pretty familiar to people who've done system text JSON things, right? It's like if it's null, write the null value and return. Else, write a start object, write the ID, write the title, write the et cetera, and then finally write the end object, right? That's what you would write by hand if you wanted like the fastest performance of how to write an object to JSON.
What I think is so great about that is that when people in my mind think about meta programming, they think about really, really late bound, really last minute app like Ruby and Python and things that are more interpreted. We're getting the best of both worlds with meta programming and all the benefits of ahead of time compilation. So it might seem like a little bit of a cognitive tax, but that little bit of extra thought is going to make this really, really performant and still allow us to have a real .NET experience. It's just going to be native, which I dig.
Yep. And so this first part just hooks up the source generator, right? Like it says, when you're trying to resolve type infos, add this to your chain, this app JSON serializer context.
Add it first, apparently.
Yeah, there's some reasons for that too. But so anyway, like here's a real app, right? Like I can run this, I can hit the to-dos endpoint, so if I go in here and I say .NET publish this.
Yeah, how big does it end up being?
Right. This one will take a little bit longer, right? Because it's got to compile a little bit more than just hello world. And so usually it takes about 20 to 30-ish seconds on my machine.
Okay.
But at the end of the day, when it gets done on both Windows and Linux, this template, what you get from .NET new Web API AOT is under 10 megs.
So you're doing a .NET Publish. Is the implication that this is .NET Publish Win-x64 simply because that's the machine you're on?
Yes. Yep. So that brings up a really good point is right now today, like cross targeting publishing doesn't work. It's super hard, and it's in my mind, it just doesn't work, right? If I'm on a Windows machine, I can't publish for Linux anymore.
Well, so I'm gonna tease you a little bit and gently push back on something, because I'm sensing from body language and tone that there's a little technical embarrassment there, but it's very reasonable because you don't have GCC, you don't have the full complete Linux stack. You don't know there's which Linuxes are we using, which libraries do we have, which like there's so much involved there. You would need a lot of infrastructure and support on Windows to go and do that. Like the easy way to do it would be to do it on WSL, on Windows Subsystem for Linux, on Windows, and let Linux do the work. You could put a ton of work into getting Windows to do that. For what? You've got Linux right there. So I wouldn't feel bad about it at all.
Yeah. Or the other way, if I'm on a Linux machine publishing for Windows, right? It's like,
which then you need a whole bunch of infrastructure and stuff.
Yep.
Yeah, that makes sense.
So here on my Windows machine, just under 9 megs, right?
Yeah.
A 9 meg app that I can just take this exe, a web server, a full-on web server, and then kind of just to prove that it works, right? As I run this, it spins up. You saw that it took a little time. Like it actually isn't that slow to spin up. Like you notice that it went really fast the second time. Like the virus scanner is kind of kicking in. Because I'm using a preview build of .NET 9, the virus scanner doesn't really super recognize these exes right away, and so it's thinking hard. Like, is this?
That's interesting. So I'm not sure if this is going to show up on the recording that we're filming right now, but I am noticing a slowdown just there. Is that Microsoft IT trying to scan this for viruses that suddenly made that feel like there's a little pokey there for us, like a little chunky?
Yeah, that very first time I ran it.
Yeah, there was a moment there where I saw the slowdown on my side.
Right. And so I don't know if it'll get caught, but like I've noticed it as well. But it's because I'm using a preview version.
Oh, you're doing a very, very new version. This is not an advertisement, but I would call out that like you're on the C drive. I've recently made a dev drive on my Windows machine, so I run everything on the D drive, and then I set it up for antivirus, async antivirus. So you would basically make a dev drive. It partitions your drive. You put all your source on the D drive. It moves the NuGet cache to the D drive, and then Windows Defender, if your IT department uses it like ours does, will lay off effectively and scan that asynchronously later because it's a trusted developer drive and it knows you're doing this work. So you get even better performance for .NET AOT in this context on a dev drive with the that antivirus. So I encourage folks to check that out. Okay, so where's our browser?
It's up and running, localhost 5000. It says, oh, this thing can't be found, but that's because there is no default.
No default route.
So I hit the to-dos, and here's, walk the dog, do the dishes, etc. Nice. Can I hit back to...
just out of curiosity, maybe this is an ignorant question, but like, what's the memory footprint? If we go and look at this in Task Manager, your 9 megs on disk turns into what in memory?
What do they call this? Hello ASP.NET. So on my machine right now, it's 9 megs. It is.
Ish.
But the thing is like I'm not giving it any load, right?
Right. Exactly.
So this is a perfect question because this is my other slide.
What? Look at us.
Yeah, it's like we planned it.
Go ahead and make that bigger, and I will go ahead and make that full screen. And then I'll
full screen this thing.
There you go.
Is it big enough?
Yep.
So what these are? So when we were doing the AOT stuff for .NET 8 in ASP.NET, we said, we need to benchmark and make sure, there's all the perf benefits that we think we're going to get, we're actually going to get, and the places where we think we're going to, be a degradation in perf, we need to measure, right? So we made a couple apps, and then what we do is we publish them in kind of a different sets of modes like that. I was talking about the different publish options before. And one of the apps is called a To-Dos API app. But this one is closer to a real world, right? There's no hard-coded to-dos. The to-dos are in a Postgres database. And so we're actually making calls to the database to get the to-dos out. And there's also like options, validation that your configuration is all set up right. And recently we actually even added in OpenTelemetry into it, right? So that way it simulates a closer to a real world to-dos web API, right? And so so there's 4 charts here, starting at the top left and then, left to right, top to bottom. We have RPS, how many requests per second can this app do, right? We have a client that just pings as fast as it can to see how much the load the server can take. And then in the top right, we have the working set, like how much memory is being consumed by the application. Bottom left is app size on disk. And then bottom right is the startup time, right? Like when I told the app to start, how fast until it was ready to accept requests.
Okay.
And then, so in this chart, there's 4 different, it's the exact same app, but it's published 4 different ways.
Yeah.
Right?
And it's not really easy to see because we don't have a legend here.
Yeah. But the legend's at the top. It's I probably could have made a little bit better.
That's cool. Do the zoom in there and let's figure these out together. Perfect. That looks great.
So the red one, it's called stage 2. It's like, throw that away in your head. But the red one is the default publish, right? It doesn't have anything behind it.
Default AOT publish.
Nope. The default .NET publish.
Okay,
so .NET new web API publish.
Okay, so reminding people of our previous slide on the far left with the jitter, we had default.
Right.
That's the red one.
Yeah. No self-contained, no ready to run, no trimming, etc. And so that's kind of typically that's about the fastest you can get, right? Because you have the JIT inside of it. It can still do dynamic PGO, which instruments your code at runtime and re-JITs it as it runs based on how, what characteristics your app did, like which paths it goes down, etc. Right? Stephen Tobe's got a really nice blog on .NET 8 performance where he really dives deep into dynamic PGO, and it really helped me understand exactly how it works.
And just to pause and like off to the corner, like if we were a book, this would be like one of those little boxes that's like in the corner of the book page. So profile guided optimization, that's what PGO stands for, means that we've run this tight loop so many times that we know more than we did when you compiled it, and we can make it even faster. And that's why it's kind of counterintuitive. Like, wait, wouldn't native AOT be faster? Well, we didn't know as much. So PGO will almost always be faster because it is simply contextually in the moment, it knows more about what it can do to make things better.
Right. It's seen which paths your code goes down, and it's like, oh, this interface is always this type, this concrete type. So just do a type check and then don't do a virtual call. Instead, just go directly to it. So,
yeah, it's really one of the most amazing things. We'll probably do a deep dive on that because it's a thing that people are getting for free that they don't realize. Okay, so that's our best.
Yep. So the red one, and then the yellow one is called trimmed, ready to run single file. So it's basically taking those 3 options and then putting it into one app, right? And you'll see
one package executable, and then trimming off the fat.
Trimming off the fat and ready to run. So you still ready to run. I don't think I've fully explained it before, but it's a form of AOT. Ready to run is kind of like NGen, sort in a way, right? I think maybe I did say it right. Like it takes your IL, compiles it into native code, and then puts that native code into your DLL again. So both the IL is there and the native code's there. And so when it wants to start, it starts faster because it doesn't need to do JIT at all. But the IL is there, so when the dynamic PGO needs to re-JIT, it can re-JIT now.
Yeah. Ready to run is a great compromise because it's like, well, I'm going to ship both of these and it's going to be bigger on disk. But if you're cool with that, we can learn a lot. We'll start up fast and then we'll get faster the longer we run. So you get kind of the best of all worlds for the price of disk space.
Great. Yep, exactly. And so you see the red and the yellow lines pretty much the exact same, which is what you kind of expect, right? Because both of them can do dynamic PGO.
Right.
The other two
probably, I
lines,
would expect a lesser working set with the trimmed one because there's less stuff loaded into memory.
Yep. Yeah. If we scroll over and look at the working set, you'll see that red line is that default published, right? Yep. And the yellow line is that trimmed, ready to run single file. Yep. Exactly what happens, right? There's less memory being consumed in that mode.
Dig it.
The other two lines are both AOT. I'm going to start with the bottom one. So this green one, greenish, bluish one, is just the default AOT. I just said publish AOT. This is the request per second I get. And you can see there's about a 15% degradation here, right? And we talked about dynamic PGO is one reason why the JIT can make your app faster, right? Like, again, you got to remember this benchmark. It's just running the exact same endpoint. It's just saying, give me all the to-dos, give me all the to-dos, give me all the to-dos. And so it's just the same exact code just getting run constantly. Here, this default AOT gets in this app gets 15% slower. There's another option that you can do on AOT called optimize for speed. And when you flip that flag on, so it's still AOT'd, and the trade-off here is like speed versus size, right? Like generate more code to make it faster, but so you're going to have a little bit more on disk. But here we're closer, we're about 5% off from what dynamic PGO is doing, right? And maybe someday we can get user-trained profile guided optimization, so where you can actually get your own run your app, get your profile, and then re-AOT. Hopefully someday that happens.
This might be just a data sampling thing, but is there any meaning that I should read into it being so smooth as a line?
This one?
That doesn't have the jitter the other lines have, and I say jitter not as a pun, but like
so you're very observant. You're very observant. We only run that one maybe once every 3 days, where the other ones we run twice a day.
I see. And
so there's less data here, like, just because I don't have the full, but there's like a whole different list of all the different tweaks we want to run, and it's just
all the combinatoric. Okay, just making sure that wasn't inherent in the technology, but rather in the data sampling methodology.
Nope, it's exactly that. There's less data points on that black code. So moving over to the working set, like that, those two AOT ones you see are much lower, right? Like if memory footprint is a thing you're trying to optimize for, here we're getting just under 200 megs of working set for the default publish. And it trims it by 35%-ish, right? Down to 120. So that's one advantage. And the reason for that is you don't have a JIT. You didn't have to load up IL into memory and then JIT it into native code. It's just, so it's not as if your app grows and it, you're going to allocate more .NET objects, right? It's not like it's always going to be this percentage. This is kind of like a more fixed-ish cost.
Tell me, this is kind of a philosophical question, but I'm feeling some kind of way that there's 4 options. And I'm wondering if this is kind of just like meat at Chipotle, where it's like, it just really depends on how you feel. There's no clear winner here. There's not one of these, which is everyone should use that one. Right. There's choice, and you could remove one of these as a choice, reduce the load on the team, reduce the effort. But these are 4 different choices because they all have value in different cases.
100% exactly. Yep. Like we don't give you just one way, right? Like the fully JITted way works great for a lot, and that's why it's the default. But again, you don't want to have to rebuild your whole app just because you want more native-ish performance with lower working set. And then like in web apps, like your startup time, like how fast are you ready to, a lot of times that doesn't really matter. But if you're like doing dynamic scaling of your app, where you're like, oh, a bunch of load just came in, I need to spin up, 10 more pods or whatever in my cluster. Sometimes startup time does actually matter, right? Or in an Azure function or in AWS Lambda, that's, scaled to 0. a request comes in and you need to start, you need to process that request. You do want your startup time to be fast. But
there's an old programmer's joke, which is, or PM joke, I guess, which is you can have it good, fast, or cheap. Pick two. Right. But like in the world of .NET and AOT, you've got like performance and you've got development speed, and then you've got like compilation cost. And you can decide, like, what do you want? Like, pick what's the thing you care the most about, and you can have two of them though. There's no one choice that's perfect and solves all the things. That's incredibly fast at runtime, incredibly fast at compile time, and doesn't require any extra and additional development time.
Ready? Yeah, kind of. There's all trade-offs. There's trade-offs all the way down.
Okay. So we're talking about AOT. That one is our green. That's our favorite. That's the one we're talking about today.
Right. And so, yeah, in this case, just real quick, application size, right? Like how much on disk, how big is your Docker container going to be? Mm-hmm. In that red default case, the whole .NET runtime is in there, right? So 100 megs is about roughly the size. If you trim ready to run in single file, it cuts it in half, and then Native AOT cuts that in half again. Basically.
And that's like what, like less than 20 megs?
In this one, yep, it's about 20 megs, exactly. And again, it's a full web server talking to a database.
Yeah.
So, et cetera, et cetera. Yeah.
What a world we live in.
Yeah, I'm excited. So I wanted to teach you how to like make your code work in AOT, right? Because as we kind of talked about, like there's limitations.
Okay.
Right? You can't just take any .NET app, every .NET app that you've ever built, and just publish AOT and it just works, right?
Okay.
And so in order to do that, I thought it'd be interesting. I heard you like AI. Is that true? You interested in AI at all?
I do a little bit of AI. I dabble. I'm learning.
Okay. So I thought it'd be interesting if you know what OpenAI is, correct?
Right.
So OpenAI, like you can make chat completions, or get embeddings for your strings to embed them for vector database searches. There's a list of other like generate images, et cetera, et cetera.
Yeah. When I would assume, looking what you've got here, you've got like the equivalent of the AI hope, hello world. But I think that underneath line 1 is probably a dependency tree that is non-trivial.
Yep. Exactly. Like I brought in the OpenAI NuGet package, right? Yep. The latest one. And that gives me this chat client object. And so I can new up one of those chat clients, and it takes two things. It says, what kind of model do you want? And so I picked GPT-4o mini, which is new, but it's smaller than the pure GPT-4. Yeah. And then it takes an API key, right? Like you have to do OpenAI, you need to sign up. I don't know, give them a couple dollars, and then you get an API key, and now you can start calling them. So yeah, there's just a quick chat loop here, right? Where it's just write out, queue for somebody to type in their question, and then send that, whatever they type in, console read line, send that to OpenAI. OpenAI is going to come back, and then we'll just write that to the console line. So if I .NET run this out, it's exactly what you think. Queue happens, and so it's like, what color is the sky? Sends it off to OpenAI. OpenAI says the color of the sky depends on what's going on, right? So pretty simple.
A lot, yeah. So in this case here, I'm kind of like thinking about the depth of that. There's SSL, there's TCP sockets getting open, there's HTTP, there's the overhead of that, there's a crypto stack, there's HTTP client, there's headers and whatever stuff is involved in creating an app like this. 12 lines turns into probably hundreds of lines and libraries that are being sucked in as well.
For sure. And so naively, I'll say .NET publish this app, and I'll say WAC P, which says set this property.
Okay.
Publish a publish AOT equals true.
Right. So that /p is the equivalent of you going into the CS proj and putting in a Boolean, but here you're doing it at the command line rather than editing the CS proj yourself.
Right. Which, spoiler alert, this is actually a mistake, right? Like, I shouldn't have done this.
Oh, wow.
And we'll see why, right?
Okay.
So my publish is done, right? It didn't take too very long. And it says it succeeded. It says, hello API, hello OpenAI, succeeded, but it gave me 2 warnings. But it succeeded, so let's try it, I guess, right?
I don't know, like they're warnings, but like how warny are they?
Right. So let's find out. So question, what color is the sky again? And immediately my app breaks.
Oh, wow.
Right? Yeah, exactly. It's like, oh,
yeah,
didn't work. So turns out the 2 mistakes I made were pretty serious, right? For one, these warnings, yes, they're warnings, but when you're in the publish trim and publish AOT world, these warnings are very serious, and like you have to at least look at them and address them. I would say 9 times out of 10, they're problems, right? Like, yeah, there's some cases where it's like, hey, I don't know what you're doing here, and you look at it, and okay, static analysis couldn't tell, but over here I made sure something happened. Like, but those are definitely like the 1% like false positive cases, right? Where you can say suppress this warning. Most of the time, these warnings will tell you things are wrong in your app, right? And so that was mistake number 1, is I ignored the warnings and I just bowled ahead and said, let me try running the app. Mistake number 2 was this setting this publish AOT on the command line. We highly recommend to set this publish AOT property in your CS proj. And the reason for that is there are what we call feature flags that get changed as you want to publish AOT or publish trimmed.
Mm-hmm.
So for example, one of the feature flags says you can't generate IL on the flyer, right? Like there's like IL ref emit. And if you put publish AOT equals true into your CS proj, when you .NET run that project, it'll run with those flags, whichever way that publish AOT is set. And so so let's just do it real quick. So if I come into my project and I say publish AOT is true, compile it. So now, if I come back here and I say .NET run, you'll see it get, here we didn't have to sit through publish, like the AOT publishing happening, right? It was the normal, just Roslyn compile and then run the IO. If I say, what color is the sky? I get the exact same error, right?
Yeah, you get a nicer call stack and cleaner understanding about what happened.
Yep. Yeah. Because this was the native AOT code, which has less information about methods and et cetera. Right. So that's why we suggest, like, highly recommend putting publish AOT, publish trimmed, et cetera, into your CS proj, is because you're going to get the behavior of your app is going to be mimicked how it will act when it's AOT'd at F5 time, at .NET runtime.
Okay, that's a good tip.
So what is this error, right? It's like, okay.
Well, is this the one you showed before where we needed to same one? Yep. Not this error. I'm saying when we did Hello World earlier, or we did a Hello World of a web API, we had to go and put in a little bit of source generator work to make our JSON.
Yep. And so like this is an instance of exactly that. Yep. It's calling, if you look at the call stack, it's saying JSON serializer dot serialize to UTF-8 bytes this object.
And it's saying reflection-based serialization has been disabled. Use the source generator API. So it's literally telling us to use JSON serializer type info resolver, which we had seen at the beginning of the show, which makes sense.
Yep, exactly. Because when you're doing JSON serializer, the only way that we can make it safe for trimming and for AOT is to use the source generator. And so walking up, one level, there's a type called binary data. saying from object is JSON,
Yeah.
that's probably like it's doing what it's supposed to do. So we go up one more level, and it's OpenAI model serialization extensions in its static constructor is calling this method.
That's a choice. That's a choice to be deserializing stuff in a static constructor.
Right. Agreed. And so let's try to fix it, right? Let's make OpenAI safe for AOT.
Let's do their work for them, and then they'll watch this, and then they'll take your suggestion and fix it.
And so I'm going to add OpenAI.
Okay, so now what you're doing is you're taking that hard dependency that pulled down the NuGet, and you're going to make it a project dependency instead of a package reference.
Exactly.
You're a star. Look at that.
Did you know about that?
That people who are watching can know that they can do this.
Yes,
right?
for sure.
You have the source available for an open source project or for your own project at your company. You start slowly working the dependency tree until you get this stuff to work.
Yep. And starting at the bottom of the stack is the best place of the dependency stack or the dependency graph.
Well, do we know if there's anything farther down?
For OpenAI?
Yeah, like what's below this?
Well, let's look at it. So it says, I reference a thing called system client model and system diagnostic source. System client model says I reference system memory data and system text JSON, which makes sense, right? Like it's doing JSON REST APIs. And this system memory data is actually where this exception is coming from here. This system binary, this binary data object is in system memory data, the NuGet package. And so I have a project reference. So that way, when I build and run my Hello API, Hello OpenAI, it's going to use this OpenAI project. And
do we make this? Does Microsoft make this, or this is an OpenAI thing?
It's a collaboration.
Okay.
It's a collaboration between Microsoft and OpenAI to make this library.
Okay. Yep. And just in case any of the folks that work on this are watching, are we like, is it nice of us to be doing what we're doing right now? Like ultimately we're making it work on AOT, but is it expected for them to have thought about this, or is this a little niche for them to have done?
I reached out to them before today and said, hey, is it in your interest to make this AOT compatible? And they're like, oh yeah, for sure. We want people to be able to do AI and AOT apps. And so, yes, the answer is yes. It's nice that we're doing this for them. Yeah.
All right. Well, shout out to them and thank you for doing that. That's cool.
So I found the model serialization extensions class that we saw in that call stack. And we know that it's from object as JSON, right, from the call stack, and it's in the static constructor. And so it's this line. And how do, so this is the line. And what this is doing is it's saying there is a sentinel value, right, like a special value called __ empty. Yeah. And I want to use that. And if you see where it's used, there's a method called isSentinelValue, this value, and it does a comparison of the memory in that binary data. And so one way we could fix this to make this actually work is to use the JSON serializer, right? Or
rather than the binary data
source generator. No, to use the source generator to say, oh, you're gonna serialize this string __ empty __. When you do that, here's the JSON type info and all that stuff. That would be one way to fix this problem. But since this is just a hard-coded value, right? Like we just have, like, there's no reason to use a JSON serializer just to turn this into a set of bytes.
Unless we end up playing whack-a-mole and they're going to go and do some JSON deserialization somewhere else, which they will. It's just for this instance, that's overkill to do a whole source generator for effectively a constant.
Right, exactly. And so for this one, we can say from bytes, and since JSON needs to be, it needs to have double quotes. A string in JSON is double quoted, right?
Right.
So we put double quotes on the string. So that way, like that's all the JSON serializer would have done is just take your string, stick double quotes around it and say, okay, now your string is now JSON, right? And we're going to use a relatively new thing called this U8 string. I don't know if you or your readers have seen this or your watchers have seen this, but what this says is in .NET, strings are normally UTF-16, right? They're two byte characters. What U8 does is it says, take this hard-coded string, but make them into UTF-8 bytes. And so you see what this is. It says it's a read-only span of T, where T is byte. And so this is the literal bytes, UTF-8 bytes for double quote, underscore, underscore, empty, blah, blah, blah.
Yeah, and that's C# 11, new in 11. We're on 12 or 13 now, I think.
Correct. Yep, exactly.
And people may not be used to that because of the they're used to like @ signs in front of quotes and stuff, but they're not really used to appended things like that.
Right. But this allows you to not have to do that transcoding, right? It's like the compiler will do the transcoding for me. It'll shove the UTF-8 bytes instead of the UTF-16 bytes into the compiled assembly. But UTF-8, this from bytes actually needs an array, right? It doesn't need it can't take a span because spans are ref structs. They can't exist on
right. And you could theoretically, hard code a byte array of what underscore underscore empty is, but that's more work. Let the compiler do the work.
Right. And so what I do is take that span and just call that toArray here. So it'll create an array one time with those bytes inside of it and set it into this set-up value.
Yeah.
So if we do that and we don't actually need to .NET publish this anymore, right? We can just .NET run. We've proven that, with having published AOT in the CS project, it'll run with that reflection-based serialization off, right? So now I can ask it, what color is the sky? And it'll actually kick off the OpenAI, give me that same thing. But we can publish it real quick if you want, just to prove that. Because now you'll also see that we won't have any more warnings, right? Like that was the warning that it gave me.
Is it, maybe speak a little bit about the idea that this is a .NET 6 standard DLL here that you're compiling with the .NET 7 SDK. Is there any considerations there to think about?
Well, so I'm using the .NET 9.
.NET 9, pardon me, I misspoke. .NET 9 SDK, my bad.
The considerations there are the SDK version that you have can build for any previous version. So you can use the 9 SDK to build for .NET 6, 5, which is out of support.
And in this case here, the OpenAI one popped into the release in .NET 6, and the top level parent Hello OpenAI console app is a .NET 8.
Right, exactly. Because .NET 6 is compatible with .NET 8. Yep. You can take a library that's built for 6 and run it on 8.
So those are both AOT. No, we didn't publish it. We did publish AOT.
So AOT, we'll get into this in a little bit, but .NET 7 was the first place where native AOT is at.
Yeah, that's why I was wondering about 6 and what that's going to mean for later.
But it will mean you're on the right track here.
Okay, I just I don't know what I'm doing. Like I'm just kind of like coasting on charm at this point. But I'm trying to understand. Like my spidey sense is telling me something's coming.
The idea is that you don't have to recompile if the code that's inside of them works on AOT. If there's no warnings inside of it, you don't have to recompile it on the new TFM just so you can use it in native AOT. You can actually take a Net Standard 2.0 DLL, compile it into your .NET 8 app with native AOT, and it'll work as long as you're not calling any APIs that don't work.
Cool. And we'll learn more about that later. And a TFM, of course, is a target framework moniker.
And so same kind of thing. There's just this little delay on that very first run because of the virus scanner. But now I get the question. I can say, what color is the sky? And it kicks off and
I'm glad it's reliable. So often it could be like, oh, who knows what the AI is going to give you a different answer for what colors the sky is every time you ask.
Yep. Yeah. Well, true. So here it fully proved like the other was just one thing that was blocking our app, right?
Yep.
But that doesn't mean the whole assembly is compatible with AOT, with native AOT, right? Mm-hmm. It was just the little bit that we used of the assembly. That's all that got analyzed, and it gave out those warnings.
Right. The one successful path. We don't have code coverage here.
Right. Exactly. Like there's a bunch more APIs in OpenAI, right? Like if you look at what's generated here, there's images and embeddings and whatever. And so as a library author, like if I was on the OpenAI team and I wanted to make my library compatible, like ensure that my library was compatible with native AOT, I guess one way would be to try to run every line of code, right, in native AOT and make sure it works. But we don't want people to do that. So we built analyzers for them, kind of two of them. One's a Roslyn-based analyzer, and then another one is the one that you already saw is when you actually publish an app, it'll analyze and it'll warn on the problems. Mm. And so to turn on that Roslyn analyzer, there's a flag that you can set on your CS proj. Mm-hmm. It's called is AOT compatible? So I'm going to set it on here. Is AOT compatible? And so I'm going to say true.
So you're saying, why do I need to say that if I've got the other AOT flags?
So
you're enabling analyzers, because what you're doing is like you could turn things on to attempt AOT, but this is almost like a meta tag to say, nah, I'm pretty sure it works now. Go ahead and give it the once over,
Yeah. So the property that I put in my executable in Hello OpenAI, that's saying when you publish this app, publish it as AOT. But in this case, in OpenAI, it's a library, right? And you don't typically publish libraries, right? You build them and then you pack them into NuGet packages and you ship them off for people to use. And so that's why there's two different flags here. Is AOT compatible is meant for libraries. It even says indicates whether a class library is compatible with native AOT, where publish is more for apps, right? Like executables. An interesting topic here, super quick, is you can actually take a library and publish it for AOT. And what that means is, so on Windows, I could take a library and have unmanaged entry points inside of it, publish that for AOT, and now it's just like a C or C++ DLL. You can take that, use it in your native app, load it up just like you would any other C++ DLL.
No way. Okay, hold up.
Native. Sorry.
No, I'm just like, my face is melting. So I could go and make a extern C, you know what I mean? Like this is and it's going to line up and it's going to look just like a C. How would I even, okay, wow.
Yeah. I think that's a whole, let's do
a show on just that, because I would love to make then a C version of the hello outside exe that called into this one.
Right. Yep.
That's crazy. That'll freak the Linux people out. Just start creating shared libraries and stuff and don't tell them it's .NET.
True. Yeah. I mean, if it meets your performance needs,
then it lines up. That's epic. Okay, I'm in. Fine.
So I set this flag and you'll see I got some warnings. And like I wanted to call this out because it was exactly what you were getting at before. Mm-hmm. This project, right, the OpenAI library says I build for Net Standard 2.0 and I build for Net 6.
Right.
Both Net Standard 2.0 and Net 6 didn't have all the native AOT annotations and whatever to get the Roslyn analyzers to work properly. Oh. Right. There's attributes that need to go on methods to say this method isn't AOT compatible. It's going to throw, or this method takes in a type and you need to preserve certain things on this type, which we'll get at a little bit later. So what this warning was trying to tell me is I just set is AOT compatible but I didn't, I didn't, I don't have an AOT compatible target framework, right? Net 7 or above. And so to fix that, I can stick in the net 8.0 compilation. And then I also need this tiny little workaround that it tells me to do right here. It says, put a condition on this is AOT compatible. And that condition is, if you're net 7 or above, then yes, you're AOT compatible. And so for the first two targets for net standard and net 6, those aren't AOT compatible, so we don't do the Roslyn analyzers on those. But for that net 8, because it is compatible with net 7, they'll get on. So I built.
What I like about that also is not only are you showing for people who may not have got to this level of editing their CS projects with MS build conditional things, you could have just arbitrarily upgraded this thing without that condition and left them in a spot where they would not be able to target 6 anymore, and now they can do both.
Right.
Very inclusive of you. Good job.
So I built, and it didn't give me any warnings, but I have a feeling that there's more warnings in here, right?
So your spidey sense is telling you that there's a problem coming.
Exactly. And so the downfall, the drawback, I said there was 2 kinds of analyzers, right? One is the Roslyn analyzers, which run on the code that you actually run against, or the code you actually build against the ref assemblies that you're referring to. The problem with that is if there's warnings in things that you're referencing, the Roslyn analyzer can't see them, right? It can't see all the code inside of all the DLLs transitively all the way down your dependency graph. And so there's the second analyzer is that dotnet publish command that I talked about, right? So this is kind of a, not the greatest dev experience today, but a thing you can do is you can build a CS proj that references your library. And then what you do is you put this trimmer root assembly. Is you put this trimmer root assembly item to say, what this says is, hey, Native AOT compiler, take the OpenAI library and pretend like all the public APIs inside of it are rooted in my app, or like are used in my app. And so analyze all the public APIs and look at all the code that they'll call. And so like this method where I have an executable referencing my library and trimmer root assembly, publishing that will give me all of the warnings everywhere, like even in my dependencies. And so my recommendation is to do both things, both turn on the Roslyn analyzers because the inner loop is so much better in those cases because you'll get, warnings, errors or whatever as you build. You don't have to do this full publish loop every time you want to fix a warning. But you'll see at the end of this, it'll spew out a bunch more.
So I want to make sure I understand that the trimming and root in this context is using the extended metaphor of a tree. Tree trimming is this idea that you grab this tree and you give it a good hard shake, and the leaves that are not used or the leaves that are not attached to a root, they kind of fall away. So if you tree trimmed console, the console class, and your application only ever called console.writeLine, you would trim away console.readLine because you never needed it. But then you might discover that someone was using reflection or something to call readLine, and then it would fail at runtime when someone looked for a class or a method that wasn't there anymore. But you're saying the root assembly, that it's not going to be removed. When you say trim a root assembly, it's not going to remove OpenAI, but it's also going to tell the analyzers to pay special attention to it. So are you not getting like you're making two statements with one property?
I mean, it's kind of that first statement is the most important. It's saying take this whole assembly and all the public entry points into it are rooted, right? Like don't cut those out.
They're not. Right? Yeah, they're not going anywhere. Those roots are in the ground.
Don't trim those out. And so then the analyzer, since they're not trimmed out, the analyzer in .NET Publish will see all the code.
I see. So the analyzer paying attention to it is a side effect of it not being trimmed away.
Right.
Exactly. That helps. Thank you, sir.
And so in this case, it's not a Roslyn analyzer, right? It's an analyzer that's looking at all the IL, even in your dependencies.
Right. My bad. Okay. That's helpful.
And so then we got these two warnings again about system memory data.
But hang on, it's running, but we're back with warnings. But the warnings are less scary than before? Because before, these warnings stopped us in our tracks.
Yep, same. It's just the reason we got warnings again is because I said root the whole assembly.
I gotcha. Okay,
and so now there's warnings coming from other methods that I haven't called yet, called.
That's good. Okay. It's not just the hot path works. This thing is not done yet.
Right, exactly. Like I turned on the Roslyn analyzers I built and you saw that there was no warnings.
Dig it.
But when I did it this other way by saying root this whole assembly and make the native AOT compiler do that analyzing, it came up with more warnings. And kind of a clue here is that this is system memory data 1.2 or 1.0.2. And if you, I don't know, go to NuGet, like one thing is most system build libraries have been annotated for trimming and for AOT. If you look, 1.0.2 was built in 2021, right?
What are we doing back there?
So OpenAI is taking like the lowest dependency that they can, just in case they don't want to like have you have to lift up to new versions.
For compatibility.
Yeah, exactly. And so, but for this talk, we're going to update this to the latest, right? Okay. I mean, that's maybe not always what you should do. It fully depends on what your
and we could update it, not necessarily the latest, but we could update it as far as, maybe just until that goes away. Like what's the lowest common denominator without that issue?
Right. And so I'm going to update it to the 8.0 version. And you can even do like, when I'm targeting net 8.0, right? You can do conditions to say, well, when I'm targeting net 8.0, then reference the net 8.0 or the 8.0 version.
Gotcha.
For the other one, still reference the 1.0.2, right? You can do those kinds of things.
Gotcha.
So I do this, and now when I build, you'll see something change. Because remember, we still have those Roslyn analyzers on, right? This is probably too small.
So now we got a flood of stuff.
Now I'm getting a bunch of errors. Yep, exactly. And so this is what I wanted, right? I wanted this experience to have like in my error list all the things that I need to do.
Right. You don't have Zoom installed, do you?
No, sorry.
Okay. No, it's okay.
I don't know how to zoom the error list.
You can't zoom the error list. You'd have to do the, actually, I'll show you a trick. If you hit the Windows key and the plus sign.
Oh, yeah. Oh.
And then, there you go. And then Windows minus will back you out. There you go. Good job.
So what this is saying is it's saying you're using binary data from object as JSON, which requires dynamic code or which requires unreferenced code. It can break functionality. Let me get back so I can...
Windows, you can hit Windows minus, and then you can close the magnifier.
And so if I double click on one of those, you'll see, yep, there it is, right?
That's in 22 places. Can we kill it all with one stone?
Sort of, yes. Yeah, not one. All of them, it turns out all the rest of them that are in here, and they're doubled, so it's not 22, it's actually 11, because one is for trimming and one is for native AOT.
Oh, good point.
And it's only 3 files, but they're all the exact same. What they're doing is they're saying, this method takes in an IEnumerable of strings, It then passes that IEnumerable of strings into this from object as JSONs. It's making a binary data, it's serializing those strings into JSON, and then taking that binary data and then calling this create moderation options, right? Which that JSON then gets passed to HTTP off to OpenAI, right?
Yeah.
And so here we do need to use the source generator, right? We were able to work around that first one. We were able to just sidestep the problematic thing, right? By not doing JSON serialization at all. But here we actually do want to use the source generator. And so you saw what I had before, right? You take the JSON serializer context, you make a class. So in this case, OpenAI JSON serializer context, you derive from JSON serializer context, and then you add JSON serializable attributes for every type that you care about. So in this case, I care about IEnumerable of string.
And these are the things you need to know ahead of time. So this would be challenging if any kind of type was being passed in. If you had an open-ended situation, that could be challenging.
It can be challenging, and that's exactly what the binary data from object as JSON method is, right? It can take any object in. Like if we look at it, it's saying
right, because it's of T, and you're being asked to constrain T.
Right. And so the way we made binary data compatible with trimming in native AOT is we added an overload to this from JSON. Why is my IntelliSense not working? We added an overload that takes in one of these JSON type info classes objects. And these JSON type info classes are the things that the source generator generates for me. So what I can do is I make the source generator, and now when I call from object as JSON, I can say OpenAI's JSON serializer context dot default dot IEnumerable string. So this thing is the JSON type info for IEnumerable of string. It has all the stuff in it to be able to serialize and deserialize IEnumerable of strings to and from JSON.
How did it, this might be dumb, but like the stuff that hangs off of dot default dot, did it generate dot IEnumerable string from you putting that line on 156 or?
Yes. Yep, exactly. Like I can F12 on this IEnumerable of string, and it'll take me into a G file.
Yeah, that's where I wanted people to see that, because that's magic, right? That's crazy. And that's something that is that happened in seconds, milliseconds inside of Visual Studio as an IDE to give you the confidence to hit dot and get IntelliSense. It generated that.
Right. In the background, it was running that source generator over my code, generating this new code into my project.
Right.
And made it available for me to call with IntelliSense up here. And so now when I did that, the warning goes away, right? And here's another one.
This feels like a bad version of Scott is you're doing exactly what I was. So you're just copy pasting. Doesn't it feel like Copilot or somebody should, or Roslyn, like there should be some way to like have a thing that says you've done this 3 times. I'm going to do it the other 8.
Yeah. In my mind, it would be even more magical if somehow, and we've tried to come up with this. We haven't come up with it yet, but if somehow we could automatically find that source generated information, and just plummet through.
Yeah.
But we haven't come up with a like deterministic, will always work, is statically analysis proven that it will work yet.
Yeah.
And so what we have today is you have to pass this source generated information into the APIs.
Interesting.
And so for this one, the input is string. So I have to pass in the default that string.
Yeah, that I can feel that. That's kind of hurt. You know, it kind of breaks the dry, don't repeat yourself.
Well, even this wasn't.
Yeah, that's not awesome
right?
either.
It's like,
well, binary data is not intuitive to a lot of people. Like when I first saw that, I'm like, oh, just use a byte array. But it's like if you're translating between strings and streams and JSON and byte arrays, binary data is very helpful and useful utility.
Right. Yeah. Binary data basically just wraps more or less a byte array, right?
Right.
A read-only
It is a
memory.
byte array, but it's got all the helper functions to let you jump around because you're always messing around. You used to be messing around with JSON, and you get a byte array, you get a string, you get a stream. I just want JSON. It's an acknowledgement of that.
But it also has the media type, right?
Yeah,
It'll tell you what are these bytes, right? So it's not just the byte array.
That's a very good point.
So anyway, I can do that for the other. I did 4 of them, so the other 7. But you get the idea, right? To like solve the rest of these, I would go into the embedding client. It's got IEnumerable of strings as input. This one also has an IEnumerable of ints, right? Which is the embeddings, though.
So then you would need to go and add that, and then it would generate that.
Right, exactly. I would, for this case, I would go back to my this one, back to here, and say JSON serializable type of, and now I would have an IEnumerable int property that I can pass into here. And I call it JSON, and then serializable context. Yep, did I not automatic? Oh, there's IEnumerable of int at 32.
Yeah, there it is.
Oh, yeah.
Nice.
Oh, I put it on the wrong line.
Yeah.
This one's the string.
Be up one.
Is it up one, or I think it's down? It's this one. So anyways, I do that for the rest of them. And now when I build and I publish that other app that routes all of the public API, now it's clean. And so the idea is, if you don't have any warnings, if your app publishes clean, your app will behave the same when it did in .NET Run and F5 with those feature flags set, right? Like I said about putting the publishing.
So I know that we're running out of time. Are we going to spike the ball and finish the last 2 or 3 and see it actually work and then call it?
Oh, do you want to?
Well, otherwise we're going to leave people hanging.
Okay. Well,
There's only a couple left, right?
Yep. So there, Copilot.
That's a string. I know somebody on the IDE team is going to watch this and they're going to say, Eric and Scott, didn't you know blah, 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 blah is a thing? And then we're going to go, oh, crap. Because I know that there are features in Copilot and IntelliCode that say, hey, you did that twice. There's refactorings for this.
Yeah, sometimes I just don't know how to make it happen.
Try hitting the little thing on the side there. Undo that and hit the little there you go. Hit the screwdriver right there.
Fix Copilot?
That'd be crazy if it worked. Let's see what it says.
It would be crazy if it worked. Oh, what does it say in here? Fix my code, please, Copilot. I mean,
this is not an ad for Copilot. We're just lazy, to be clear.
Oh, geez, it generated a bunch of stuff.
No, that's not what I wanted. That. Just give that a thumbs down.
Oh, sorry. I'm.
All right. Oh, you got an extra comma that you threw in there.
Oh, did I?
Yeah.
I do that sometimes.
Well, I don't know. You're moving pretty fast.
Let's go back up there.
I heard that comma on your fancy programmer keyboard there.
It is
those cherry red.
It's a Microsoft split. It's not that fancy.
Oh wait, dude.
Twin. You got the same? Samesies, yeah, nice. It's the most comfortable one. I'm sorry.
You may not like it, but this is what peak performance looks like.
Oh, and here's a new one. Read-only memory of float, which we should have known that was coming because that's all AI is just floats all the way down, right?
Yeah.
I'm here. So we need to do one more.
Superstar. And then I also want to call out his excellent use of the clipboard history, which you can get by hitting Windows key and V. And if you get Power Toys has an even more advanced clipboard history feature as well.
how advanced? What does it do for me?
Oh, dude, it's called advanced paste. You throw your OpenAI key into it, and once you have an OpenAI key, you can paste as whatever. So if you have JSON, you can say paste as XML, and it will use AI to switch between JSON and XML. Or you could have a PNG in the clipboard and then paste as text. It's
Okay.
it's advanced AI powered paste. I think it's up your alley. You should check it out and tell me later.
I should check it out. So now my Roslyn analyzers are clean. I publish this app one more time that says, root the whole assembly. And then this should be clean as well.
We're on 8, core compile. What is the difference between core compile and IC? It was like ILC compile?
So core compile is Roslyn compile. And ILC, gotcha. So it's taking your C# code into IL, and then ILC compile is taking that IL into native code.
It's the last.
What do you think about the .NET 9 SDK change here on, I don't know if many people have seen this yet, on how...
Well, one of the things that I'm noticing, and I'll move us out of the way to see it, is you've got the timers on the side. You've got the, I know that you're using Oh My Posh, it looks like, with some nice segments. And then you've also got the right aligned timer there. It looks like we're starting to really care about the command line. And I'm noticing that you're, in this talk, you've run around Visual Studio Code, and the command line, picking what was appropriate for the moment. And I encourage others to because you were like alt-tabbing and hitting .NET Run when you could have hit Control F5 because you got a cooler and a more valuable experience. But then you switched back to using Error List, which gave you a different experience. So it was cool to watch you use different tools to get the job done.
Yeah. I mean, the reason I've done it run in my command line is because I needed to type in, type in what color is the sky, and I don't want to do it in some new window that gets.
Let's end on running that. And let's ask
this whole app.
Yeah, let's go ahead and run the app, the actual app, not .NET Run, but like get in there. And then ask it if it's a fan of the Deep .NET series on YouTube.
That's the thing. So that's a ability to watch videos.
Useless. AI will never work.
Nope.
Awesome. Well, that is super educational, man. And I guess you could go and PR that now to the OpenAI friends if you wanted to.
Agreed. Yeah. So they're we hinted at a couple, multiple other talks, right? Like there's so many facets and so many places we could go and talk about in this, right? Like this is just the intro, what it is, why you'd even care about it. And then we just fixed a handful, really only system text JSON warnings, but there's all sorts of other APIs that you use that you're going to get warnings for. So call out a couple of ideas of future talks, and I want folks to comment in the chat if one is more interesting than the other, and if you'd like a series on this kind of stuff with Eric and I. So ideas, for one, is the deeper on how does native AOT actually work, and what are all the switches? I talked about the speed op switch, but there's also switches where the SIMD instruction sets, you can say, compile this for these instruction sets, right? The deep, get Mikhail on here kind of thing and say, so have him talk about native AOT.
I've been trying to get Mikhail on my podcast for years. I need to get him to follow me on Twitter first. But that would be great. I love it. And I love that we're getting more people from the team to talk about this stuff. Yeah.
Other ones would be the Maui team is experimenting and working on getting native AOT to work on iOS and with Maui apps, and their perspective is going to be a whole lot different than mine. Is kind of library centric, right? Where they're more on an app model centric, deeper into performance, etc. So,
all right, that was fantastic. That was 90 minutes free workshop with Eric Erhardt on AOT on deep.net. That was fantastic. Thank you for your generosity and for your time and for teaching us this stuff. And hopefully we'll hear from folks in the comments, and we will plan out the next several episodes.
Yeah, sounds great.